Okay, so I put these up. I'm just starting to record right now. These are from the quiz, the ones that people struggled with the most. I want to do these one more than a few others. Closed captioning is on. If Zoom freezes for some strange reason, hang in there, don't quit. I will log out, log back in. It may take me a few minutes. Sometimes I can just log in. Sometimes I have to shut down my whole computer and restart the whole damn thing. I don't know. I don't get it. But anyway, don't panic. I'm still testing whether or not it freezes. So here we go. We've got what I call a power equation. Okay. When we're being asked to solve a power equation, it's already equal to 0. That's key number 1. And it's in order from highest power to lowest power. Okay, so I run through my checklist, and that is, okay, do they have anything in common? Well, yeah, they do. X, I can factor out an X, that leaves X minus 5 equals 0. Do they have anything else? Could this be a dose or a trinomial or a grouping? No. Okay, no to all of those, and I'll go over that if you have a question. So then we go through it. It did equal 0. We factored it. Now we split it up and we solved what I called the babies. We say either this equals 0 or this equals 0. So we split it, okay, because X times this mess, factoring allows us to do that. Solve. This is already solved. This one we add 5, so X equals 5 to both sides like that, and then bring them together in a single solution set. And that's it. And I have no idea why people didn't get that one correct. That was one of the easiest ones on there. Okay, so that was problem number 13 from the chapter 7 quiz. This is problem number 14 from the chapter 7 quiz. Okay, again, it already equals 0. Yay for small favors. It's already in order. Highest power, next highest power, lowest power. So we run through the checklist. First, we always try to do what they have in common. So I'm looking at these and I go, hey, I can pull out a 2 and an X out of everybody. And remember, we're not pulling out, we're technically dividing out. So when we divide 2x out of this, it makes 3x squared plus 5x minus 2 equals 0. Okay, so we pulled a 2x out of everybody. I don't think I've screwed up. I'm going to do my very best not to repeat last night. Last night was kind of embarrassing. I really effed up last night. However, we're not done factoring this time. Just because we've taken out what they have in common, I have to look here, and what I see here is a trinomial, and maybe it factors. I have to consider that. Okay, so to factor it, we use the AC. So if AC is -6, 3 times 2 is -6, that's AC. So what times what multiplies to make -6 and adds to make +5. That's the game. Multiplies to make -6 and adds to make the +5 in the middle. Well, I get 6 times -1. 6 times -1, timesing is -6, adding is +5. Okay, that allows me then to take, forget the 2x, we're just going to bring it down here. This becomes 3x squared plus 6x minus 1x minus 2. Okay, that's how we use that. We put, so this is still 5x, but we've kind of written it differently. Then we okay, Put a parenthesis around the first group, put a parenthesis around the second group, making sure to leave the minus sign in between. But this is one of those trick questions. This problem with the parenthesis is not the same as this problem here. Because in this problem, it was a -2. But in this problem with the parenthesis, if we distribute, it's a +2. So this is one of those ones I said, okay, we just have to kind of cheat and fake it. Now, okay, if we distribute the -1 in, that 2 will turn into a -2. So now these two are the same. This and this are the same. So now we factor. Okay, this one we can take out a 3 and an x out of this, leaving x plus 2 minus, okay, we talked about this last night. When you can't take anything out, you can always take a 1 out, leaving x plus 2. You factored a 1 out. These two are the same. Okay, so factor them out front. So we have x plus 2 times 3x minus 1. And we bring down the 2x. And so it equals 0. So hang on, we're not done yet. But all of this work, I took the original problem and using all of my factoring skills, common and then trinomial, I turned this problem into this problem. They're the same. They're exactly the same, except the new form is all multiplication. Okay. I am going to skip a step. We're supposed to split it and go, okay, that means 2x equals 0. Or where's my glare? Okay, I'll come down here. X plus 2 equals 0, or 3x minus 1 equals 0. Okay, those are what I call the babies. We take these factors, this factor, this factor, this factor, set each one equal to 0, solve each one of these, and if life is good, we should get, I'm not going to show it unless you guys ask me, but we should get 0, -2, 1/3. That's the answer to this problem. Now, if anybody wants me to show more steps, I'll be happy to. Okay, this was a tough problem. It had all kinds of things. I think last week, Bach had indicated that he didn't like having to factor out a 1. That kind of bothered him a little bit. So he, instead of writing 6x minus 1, he flips it around as -1 plus 6x. And that, in his mind, made the factoring easier, which is great. As long as you get an x plus 2 and a 3x minus 1, you're cool. You're okay. It doesn't matter. And remember to bring down the 2x because it's one of the factors also. All right, so that's 13 and 14. I don't know. I mean, we've gone over it. Yes, those are on the exam tomorrow. Okay, but the exam doesn't have a whole lot of chapter 7 stuff, so don't panic too much. Any questions about 13 and 14? I need to erase to put up a new problem.
No.
You sure? Everybody else? Okay. Then the next problem on the quiz was that Pythagorean one. And it said, I'm paraphrasing now, in a right triangle, comma, the shorter leg, or the short leg, is 2 less than the longer leg. Can't spell. If the hypotenuse is, what was it, 10, find the length of the short leg. So in a right triangle, that's the first phrase there. So we automatically know we've got a right triangle. Okay. And it told me the hypotenuse was 10. So I can fill that in pretty easy. Remember, the hypotenuse is opposite the right angle. And this is where now the English comes in, the words come in. This is the short leg. This is the long leg. It doesn't matter who's short and long, but the problem itself was talking about, hey, there's a short leg and a long leg. So somebody's short and somebody's long. But here's the key. The short leg becomes equals to less than the longer leg. Well, less than means subtraction. So if this is the longer leg, this has to be the shorter leg. The shorter leg has to be 2 less than the other leg. So this had to have been x, this had to have been x minus 2. Now there was an alternate way you could have set this up if you had a little bit of English proficiency here, but this is the way the problem was set up. The short leg is 2 less than the longer leg. So whatever the longer leg is, x, then that's got to be the short leg, 2 less than that. And then it's because this was a right triangle, we can apply Pythagoras. So we have x squared plus x minus 2 quantity squared equals 10 squared. Okay. Do you guys want me to let you finish it, or do you want me to go through it? You guys want to try and finish it, or do you want me to go through it? Anybody?
Can you go through it?
Me? Okay. Are you okay with this so far, though?
Yeah, I got this part, but after this, I don't know what to do.
Ah, okay. Well, then now we're gonna multiply these out, or you may have heard of FOIL it out, whatever. But what you're gonna do here is you're gonna call this x squared plus, this is x minus 2, because that's what squaring means, times it by itself equals 100. Now, the most common place that people are going to make a mistake is right there. They're going to multiply that out wrong. Okay, to do that, go off to your scratch paper and have x minus 2, x minus 2. Remember how we multiplied polynomials? I showed you that you could use this box or this matrix. If you know another way, fine. I don't care. I just care that you get the answer. So when you multiply the matrix here, you get x times x is x squared. X times minus 2 is minus 2x. Minus 2 times x is another minus 2x. And minus 2 times minus 2 is plus 2, plus 4. Come on, dummy. So when we add like terms, okay, we get x squared minus 4x. So minus 2 more is minus 4x plus 4. So back here, that's my scratch work. I get x squared plus that work. X squared minus 4x plus 4 equals 100. Are you with me or not? Everybody. Any questions or hesitation so far?
No.
Okay, okay. So now that I've multiplied that out, foiled it out, or whatever you want to call it, now it becomes just a power equation, just like we were doing a couple seconds ago. It must equal 0, and the powers have to be in order. So I'm going to skip a quickie step, but I'll explain where it came from. If I have x squared and x squared, I have 2x squared minus 4x minus 96 equals 0. Remember, I want my power equation to equal 0. That's the game. First step, must equal 0, and the powers have to be in order from highest down to lowest. So all I did here was add x squared and x squared and took 100 away from both sides. Okay. Now it becomes a factoring problem. What can I do? Well, at the very least, I can factor out a 2. Okay, leaving x squared minus 2x minus 48 equals 0. Factoring out means dividing out the common 2. Okay. So here we go again. Can I erase this thing that I used to help multiply?
Yes. Yes.
Okay. No one's going to yell at me. All right. So here we go. Okay. This is a trinomial, so I get AC is negative 48, because remember, there's an invisible 1 here for the A. 1 times negative 48, negative 48. So that's going to be 6 times 8 is 48. But wait, I got to make a negative 2. So the 8 has to be negative and the 6 has to be positive. Okay. So those are my magic numbers. But wait. Okay. This is even cooler. Remember, this is that shortcut. Because the A value is 1, I don't have to go through all that grouping crud. Okay, I don't have to do that. I can just use these numbers directly. So I get 2x plus 6 because of that, parentheses x minus 8 because of that, equals 0. You can only use that shortcut when that's a 1 on the coefficient of the x squared is a 1. But that's a really powerful shortcut. That's a cool shortcut. Now, if you wanted to do all the grouping and all that kind of stuff, go right ahead. You're going to get the same answer. Okay, separate it. Technically, we say either 2 equals 0. Let's go back. Hang on a minute. What this says is, because I factored this problem and this problem are the same, they're just written in different format. They're all worth the same, but now it's a bunch of multiplication. 2 times this times this. So that zero product property thingy says either the first thing equals 0, or the second thing equals 0, or the third thing equals 0. Okay. Well, 2 can never equal 0. So we just simply reject that. And like I've said, most instructors don't even bother to write that down. That's just ludicrous. 2 can't even be close to 0, so don't even bother writing it. I do it for consistency's sake. Solve this one, we get take away 6 from both sides. X is negative 6. This equals 0, I'm sorry. Add this one, X is 8. Okay, now think about this. Okay. Okay, X represents the longer leg. Okay, again, we come back to this is a word problem. This is more or less reality. You can't have a length that is negative. You don't have a ruler that can measure negative numbers. So this is a reject. Okay, we can throw that out because you can't have negative numbers. And we kind of talked about that a little bit last night. So the only answer for X, okay, is 8. But that's not the answer to the question. And this may be kind of where people screwed up. They waded through all this stuff, fine. But the problem says, what's the short leg? What's the length of the short leg? Well, you found X, but we said over here, X is the long leg. So the short leg has to be X minus 2. Okay, so you had an extra step. You had to go that the short leg is 8 minus 2, which is 6, whatever your units were. So the short leg in this problem was 6. Okay, so that was a problem. If I recall correctly on the quiz, it said 85% of the people got it right. So somebody screwed up. The two things I can think of that people screwed up on were, one, okay, multiply this out wrong. Okay, you didn't get this. And or two, you probably just said your answer was 8. Okay, which is what X is. X is 8. But the problem wanted you to go one step further. It said, what was the short leg? And over here, we had said X is the long leg. So you had to do this extra step to find the short length. Okay, there's lots of places you could have screwed up on. So those are 3 problems from the quiz that I noticed they were the lowest in terms of correctness, lowest percentages in terms of correctness. Everything else was over 90%. So people were doing great on that. Any questions on this problem? You're sure?
I have a question
Yeah.
about the AC number.
Yeah.
So how does it have like a chart for us to look at? Like when you see 4 minus 48, you know right away it's a 6 and an 8.
No, you just run through your times tables. When you go negative 48, you think, okay, that could be 1 times 48, 2 times 24, 3 times 16, 4 times 12, not 5, 6 times 8. You just kind of run through your times tables very quickly and see which ones even come close to making a 2.
Okay, I see. So we make up timetables for that number.
Yeah, but you can save yourself some time by just kind of running through them in your head. But this is what you should be doing, just going through your times tables, just like you said, okay, multiply and now go, okay, 6 times 8 is 48, but now I got to make it negative and I got to make it add to negative 2. So now you start playing around with your positive and negative symbols. Okay?
Okay, thank you.
Sure. Anyone else? Okay. I'm not sure it's good for me. No, I'm not going to do it tonight. I was going to show you how I actually factor some of these, and very seldom do I actually use the AC technique. Okay, I've got another technique, but it requires that you know your multiplication tables forwards and backwards, inside and out, and can add and subtract numbers quickly. Okay, but I get it done in half the time. Okay, but I don't think I show that to you now. I'll wait till next chapter and show it to you. Okay, it's got a cool name. It's called the belly button, but I'll worry about that one later. Okay, so I want to erase. Does anybody remember anything from the quiz that they want me to cover? Any particular problem that kind of bugged you, and while I'm still talking about the quiz, you want me to do it? Okay, then excuse me. I thought maybe you guys would have trouble with this. Solve this inequality, less than or equal that, and solve this inequality. So let me pause it and let you guys work on that for a second or two. So here we go. Do the first one. I'm going to take x away from both sides. That's going to give me 5 minus 4x less than or equal to negative 7. I'm going to take away 5 from both sides. That's going to give me negative 4x less than or equal to negative 12. Okay, and now comes the trick. I'm going to divide both sides by negative 4 because I want to get x alone. That's always been our goal. And on almost every equation, get x alone, x alone. So this is x, this is 3, but it's an inequality problem, and you divide it by a negative. So you have to flip the inequality symbol over. Okay. If you stop here, this is known as set builder notation, but I added that I want you to use interval notation. Interval notation mimics what the graph would look like. So if we graph this, here's 0, here's 3, okay? X is greater than or equal to, so solid dot on 3, shading this way. So interval notation mimics the graph. Literally, it would be bracket 3 comma parenthesis infinity, like that. And that would be called interval notation. Now, you did not need to write the graph. I did that as a teaching moment or a teaching tool because interval notation mimics exactly what you see on the graph. On the graph, you see 3 and bigger. And that's what 3 comma infinity means. Okay. Over here, this was called a compound inequality. Compound means multiple inequalities in one problem. So in this one, this is kind of like a trick question. X is in the middle and you want to get it totally alone, meaning you want to get rid of the 1 and you want to get rid of the 3. So the game we play here is we take away 1 from all 3 sections. So negative 8 take away 1 is negative 9 is less than or equal to 3x, which is less than 15. Okay. Divide everybody by 3 because you want to get x alone. So this is negative 3. 9 divided by 3 is less than or equal to x is less than 5. Okay. Again, this would be called set builder notation. It's graph, literally, I'm not going to really explain it to you, but it says literally x is in between 5 and negative 3. That's what it says. X is in between 5 and -3. Okay, so that's what your graph would look like. Okay, but in interval notation, it would be bracket, -3, comma 5, parenthesis. So a couple things I want to make sure, there's a couple ideas here. First, when solving what's called a simple inequality, you have to remember that you flip the inequality symbol if you divide or multiply by a negative number, in this case, -4. You flip the inequality from less than to greater than, or greater than back to less than. Okay, this was called a compound inequality. Okay, it was, well, it's like 2 problems for 1. So the game was to get the X in the middle totally isolated, get X by itself. So that was getting the basic answer. Then it was converting that answer into interval notation or interval notation. Interval notation is definitely new to you guys this year. Most people have never seen it before, so that's confusing. Some people have never seen a compound inequality before. Just about everybody should have seen a basic inequality where you have to flip the inequality. All right, any questions on either of those? Those were 2 problems. I was just kind of thinking, okay, what have they forgotten? Because these were way back in chapter 2. And we've been focusing on other stuff. Any questions about either of those? Nope. Can I erase? Anybody gonna yell at me? All right, this is like a wedding. Complain now or forever hold your peace. Okay. One we haven't done in a while. Find the equation of the line that passes through what do I have? 5, -2, oops, and 7, 6. That would be one problem. Second problem, solve this equation. 3 times 5x minus 4 minus 7x equals crud. 2 times 4x minus 9, close parentheses, plus 6. Let me see, did I copy it right? 5x minus 4 minus 7x, 2, 4x minus 9, plus 6. Yeah, so I'll put a pause on, let you guys work through that. Okay, so let's go back over here, find the equation of a line. Okay, I need 2 things. I need a point and I need a slope. Always, when it says find the equation of a line or determine the equation of a line or something like that, you need a point and a slope. Well, I got points all over the place. Okay, it doesn't matter which one I use, I got points. What I don't have a slope. So what you have done, however, is you have memorized the slope formula. Slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's the formula for calculating the slope. So we have 6 minus a minus 2, because that's y number 2, the second y minus the first y. Notice there's an extra minus minus there. The formula has a minus in it. The fact that the second number happens to be negative, that's just bad luck. But you have to go with it. And then 7 minus 5. Second x minus first x. So the top becomes 8. The bottom becomes 2. So my slope is 4 or 4 over 1. It doesn't really matter in this case. That's my slope. All right, now I have to find the equation. To find the equation, one way to find it. Remember when I introduced this, I said there are probably 4 or 5 ways that are used across the world, okay? The way I was teaching you is the way that most students and most teachers use. I don't particularly feel it's the best way, but it's the way that everybody else does, so I didn't want to fight everybody. But we start with the formula y equals mx plus b, and we plug in everything we know, okay? I know I'm going to use this point. When y is 6, the slope is 4, x is 7, plus b. So the first time you use this formula, you just plug in everybody you know. So that's 6 equals 28 plus b. If you take away 28 from both sides, you get negative 22 equals b. Well, now you come back and you plug it in, but you're a little bit more carefully. We plug in only the m and the minus 22. And that is the equation of the line, okay, that goes through those 2 points. Guaranteed, when you graph that line, it'll go through that point and that point. Okay, moving on to this one. Solve this, okay? Well, first step almost always is get rid of parentheses if you can. So we're going to distribute. So we can have 15x minus 12 minus 7x equals 8x minus 18 plus 6. Combine like terms on each side. So on this side becomes 8x minus 12. 15 take away 7 is 8x minus 12. This also becomes 8x minus 12. Uh-oh. Okay. If we go even further, if we take away 8x from this side and keep it balanced from this side, we end up with negative 12 equals negative 12. Our x's dropped out. This is what I call the WTF problem. Okay, it's a trick question. Because this is true, negative 12 equals negative 12. And by the way, it didn't have to be negative 12. It could be 5 equals 5, 6 equals 6, okay? 0 equals 0. It doesn't matter. What matters is there's no variable and it's true. That's what matters. Because there's no variable and it's true, we call this an identity. Okay, or at least mom calls it, and lots of teachers. Other people use a fancy script R. Other people say negative infinity to positive infinity. What all of that means is, okay, that every number in the world, all the real numbers, or all the numbers from negative infinity to positive infinity, all of those numbers would make this problem true. Remember, generally an equation has 1 or 2 answers. We've seen in chapter 7 that our equations have 2, maybe 3 answers, that kind of stuff. Okay, but this is saying, oh, no, not just 1, not just 2, a gazillion numbers. Any number you pick from negative infinity up to positive infinity makes this problem true. Okay, again, I will accept any 3 of these answers. They're all okay. Actually, there's a 4th, but don't worry about it. Okay, so we haven't talked about equations of a line for a while. I figure, okay, maybe one of those to help you a little bit remember. And we haven't talked about weird equations, okay, with trues and falses and stuff like that. Any questions on either of those? Okay. Then I want to do 2 more problems and quit, unless you have questions. And I don't believe, well, let's start with the first problem. How do you factor this problem? Let's take a second. I'm not even going to turn off the recording. Just I want you to factor that problem. Okay. You're supposed to look at this and you're supposed to go, oh, this is a dose problem. Difference of 2 squares. Difference means subtraction. Can I write this as a square minus a square? This is what you're supposed to be thinking. You don't have to write it down. You can think it. But you go, yeah. If this had been a 3x quantity squared, and this had been a 4 quantity squared, okay, then my answer is 3x minus 4 and 3x plus 4. And that's just the answer. Use the 3x and the 4 twice, but one of the binomials is a minus, one of them is a plus, and it doesn't matter which order they come in. Okay, now that's pretty straightforward factor of a dose problem, difference of 2 squares. Now, this is a trick problem, and it is not on the exam, not yet. It might be on one of our chapter 8 or 9, chapter 9, probably on chapter 9. It might be there when we come back. But I want you to factor, okay, x to the 4th minus 16. So I am going to pause the recording right now, and I want you to factor x to the 4th minus 16. Very easy to get it. Remember, don't panic on this one. It is not on this exam, but I want to show you this. All right. Well, first off, it sure as heck looks like a dose to me, because I can write this as somebody squared minus somebody squared. Now, it's a little bit trickier, but this would be x squared squared and 4 squared. X squared squared. So if I follow the rule, the pattern for difference of 2 squares, doses, this becomes x squared minus 4 and x squared plus 4. Okay, that's using this as my think step. I'm thinking this, and this is my answer. Unfortunately, it's not your answer. Okay, it's partway to your answer. But this turns out to be another dose problem. Okay, because this could be somebody squared minus somebody squared. Okay, but what about this? What about the x squared plus 4? Can you do anything with it? And the answer is no, you can't. It's not a dose because the D stands for difference or subtraction, and that has a plus sign. So that particular part of it won't factor. But we can keep factoring this. This, remember, becomes x squared, x and 2. So here we go. This becomes x minus 2, x plus 2. And this didn't factor, so it comes down to x squared plus 4. And that would be the answer for this particular problem. It factors more than once. Okay? And with tongue firmly in cheek and laughing at the pun, it's a double dose. I don't know what that means, double dose. All right, I just want to show you that. We're going to get more factoring in chapter 8, more factoring in chapter 9 of this style, trickier even. And then we'll get problems that can't be factored. So anybody have any questions on either what I put up here on the board, or during all my babbling, have you come across another question that you want to ask?
Yeah, I have a question. It was on one of the quizzes is solve the system of equations.
Yeah.
I got y equals minus 5x minus 9 and y equals minus 5x minus 5.
Okay. Okay, hang on. So we want to solve, and you had y equals
Minus 5x minus
Minus-
9, and then y equals minus 5x minus 5.
okay. All right. If we do this in two different ways, if I were to graph this, is that thing going in and out of focus? It's not supposed to. Or is it just my eyesight shot? Okay. If we were to graph this for just a second, what would happen is the first one would have a y-intercept of -9, and it would look something like this. Okay. The second would have a y-intercept of -5, and it would look, whoops, something like this. Okay, 0, -5. Notice both of these have a slope of -5. Okay, meaning they're parallel. That's what I'm getting at. These two lines are parallel, so there is no solution to this problem. Because when you're solving a system of equations, you're trying to find out what do both of them share? Where do they cross? Okay, now that's just, I happen to see this. You probably would not think to graph it because everybody hates graphing. So let's go after it a different way. We can either use substitution or we can use addition, elimination, your pick. Okay, if I were to use substitution, okay, I would look at this one and I say, oh, look, I can put this y in place of this y. So I can write, instead of y equals -5x minus 9, I can write -5x minus 5 equals -5x minus 9. Because look what I did. I substituted in place of y this quantity because it told me y is worth this. So in place of y, I put this. Okay, well, if we continue, if we add 5x to both sides, we end up getting in algebra -5 equals -9. Okay, that's a WTF problem, but this time it's false. So there is no solution. So, and I can do it a third way also, but the idea is if we had graphed these, we would say the slopes are the same, so we know they're parallel, and the two lines never cross. So there can't be a solution. If we did it purely an algebra way, and I did it by substitution, okay, if y equals this and y equals this, then they have to equal each other kind of thing. We still get a weird algebra statement, -5 equals -9. That's just not possible. So we know there's no solution. So any way you do it, there's no solution. And the correct way is to write the solution with nothing in it, but I don't think mom cares about that. So how's that for an answer, or do you need a better one?
It's good.
Okay, all right. Good question. Good question. I like the weird ones. We get so wrapped up on the nice, pretty ones that we forget that there will be weird ones. Others, anybody else?
I have a question.
Sure.
I just don't remember how to solve these type of problems. So it's 3 and then bracket 3 plus 4 and then parenthesis 3 times 2 minus 4 parenthesis and then end bracket.
And what are we doing to it? Does it say solve it? Is there an
It
equal
says-
sign, or does it just say simplify it?
There's no equal sign. So
There's no equal, so it's just simplify.
okay.
Okay, so let's look at it again. All right, so repeat it for me again. 3,
3 and then bracket 3 plus 4 and then in parentheses 3 times 2 minus 4 end parentheses and then end bracket.
got it. Okay, this is just getting you to do arithmetic following PEMDAS. Okay, it's not an equation. You're not solving it, but you are simplifying it. There's a difference. Solving it means find x. You're simplifying it. And you're using PEMDAS. You know what I mean when I say PEMDAS?
Yeah.
Okay, so in PEMDAS, okay, when there's a bunch of grouping symbols, which there's brackets and there parentheses, we always start on the inside one first.
Mhm.
Okay, so we're going to do in here, but let's go back over PEMDAS for a second. PEMDAS. The P stands for grouping symbols. The E is exponents. Okay, M is multiply. D is divide. A is add, and S is subtract. Okay, what this tells us is the hierarchy. Who is more powerful? Who do we do first? And check it out. Multiply is more powerful than add. Okay, multiply is more powerful than add. So when I'm looking in here, in this parentheses, I see that I have to multiply and subtract. Well, actually, multiply is more powerful than subtract too. So the first thing I have to do is multiply those two. Okay, so if I showed almost every stinking step, and you don't have to, you do that, close bracket. Well, 6 minus 4 is 2. Okay, so here I go again. Okay, inside of this bracket, it's asking me, do I want to multiply 4 times 2, or do I want to add 3 plus 4? And again, multiply is more powerful than addition. So I do the multiplication first. So I have 3 bracket 3 plus 8. So inside here, I go 3 bracket 11. 3 times 11 is 33. And that's it.
Oh, okay.
Is that okay?
Yeah.
Okay.
I have
Anybody else?
another one.
Sure, go ahead.
Okay, sorry. It's there's no equal sign for
Okay,
this one either, but it's minus,
go ahead.
it's minus or negative 5v minus 6a minus 4 minus v plus a.
And did it say anything
Wait,
else?
no, it's the
Z,
v.
a B,
It's 5v and 6a and then
minus
V.
4,
yeah, minus v plus a. No, v. Sorry.
V as in
Yeah.
Vic, and this is a V there.
Yeah.
Okay, all right. So plus A. Okay, so what they're trying to get you to do is just simply add like terms.
Mm-hmm.
That's all they're trying to get you to do. So in this case, the negative 5V and the negative 1V would be considered like terms because they're both V's. And the rule for like terms, remember when we say if we have 2x plus 3x, we have 5x, when we're adding like terms, we actually add the coefficients. 2 plus 3 is 5. So here, negative 5 minus 1 is minus 6v. Okay, now we look at this, we look at the other like terms. We have a minus 6a and a plus 1a. So minus 6 plus 1 is minus 5a. And then the minus 4 just didn't combine with anybody, so it just goes along for the ride, and that would be the answer.
Okay.
Is that okay or not?
Yeah, yeah, I get it.
Okay, it's just adding like terms, and it's got these invisible ones here that you got to remember to do something with. Okay, others? Or do you
Yeah,
have-
I do have
keep
another
going.
one. Okay, so 10 over 3x
10.
equals, yeah, equals negative 1/3.
Okay. This problem right here, right? 10 over 3x. All right. There's a bunch of ways this could be done, but the easiest way is to see this as a proportion. A proportion is when one fraction equals one fraction. Nothing else. Now, if there had been a plus 3 out here or something like that, then we're screwed. Then we got to do it a whole different way. But because it's one fraction equaling one fraction, this is called a proportion. And to solve a proportion, we can cross multiply. Top times bottom equals top times bottom. So 10 times 3 equals 3x times negative 1. That's what you're doing. 10 over 3x, negative 1 over 3, multiply bottom times top, top times bottom, like that. Now, it doesn't matter who you write first. This is 30. This is negative 3x. It doesn't matter what side to put the 30 on and the 3x on. That doesn't matter at all.
Mhm.
What matters is when you do your arithmetic, you're going to divide both sides by negative 3. Okay. And that's going to give you 10 equals, or negative 10, 30 divided by negative 3 is negative 10 equals x. And that's your answer. Okay. Okay. This was probably solve or something. Is that okay?
Yeah.
Now there's other ways, but this is far and away the easiest, bestest way.
Okay.
Okay.
Mhm.
Others? Or do you
Yeah.
have more?
Yeah.
You have more questions?
But does anyone else have questions? No.
Yeah. Anybody else? No, you just gotta let her carry the show, huh? All right, keep going.
Okay, so there's another fraction one. It's x minus um 3/8 equals 5/8.
Okay. This is a solve. Now, this is not a proportion
Mhm.
because it doesn't have one fraction equaling one fraction. It's got a whole bunch of junk. So we got to go after it a different way. There are two ways that you can do this problem. Okay. First way is, what if you add 3/8 to this side and add 3/8 to this side? Then we get x equals, all right, how do you add fractions? You go 3 plus 5/8. The rule for adding fractions is add the tops, keep the bottom, keep the denominator. So this gives me x is 8/8, which is 1, and we're done. That was it, just adding 3/8 to both sides. And 5/8 plus 3/8 made 8/8, which reduces to 1, and I'm done. Okay. There's an alternate way this could have been done. So if we took the same problem, x minus 3/8 equals 5/8. And last night we talked about something called the LCD. If we multiplied everybody by 8. So we distribute the 8 here. I'll move in a second. 8 here, 8 here. So 8 is the common denominator. If we multiply everybody by 8, right, we get 8 times the x minus 8 times 3/8 equals 8 times 5/8. Now what's going to happen here, this is going to be 8x. What's going to happen is 8 times 3 is 24 divided by 8. It'll just simplify to 3. Or these 8s will cross cancel with each other. Equals 8 times 5 is 40 divided by 8 is 5. Or you could say they cross cancel. So then you add 3 to both sides and you get 8x equals 8. If you divide both sides by 8, you still get x is 1. So there's this particular problem had a couple of different correct ways of doing it. Okay or not okay?
Yeah, I got it. Thank you.
Okay. Others? More?
Yeah.
Okay.
7x plus 6y equals 18, and it says solve for y.
Okay. Solve for y means we want to get y alone.
Mhm.
So the first thing I would do is take away 7x from both sides. Okay.
Yeah.
That's going to give me 6y equals. Now, since all it's saying is get y alone, normally we put the x in front, but you could have just as easily done 18 minus 7x. That doesn't matter.
Okay.
Okay.
Mhm.
You could have either put the x in front or not. But now, wait a minute, we're not done. Because when it said solve for y, it meant get y completely by itself. So you want to divide both sides by 6. So divide this, that gets y alone. Okay. Now, here's a problem. This right here is a correct answer for those instructions. For the instructions you gave me, it just said get y alone. Okay,
Oh, so
but
that's it?
so that would be it. But sometimes the instructions would be different, and they would ask you to separate this out. Okay, because you're dividing everybody up here, you divided everybody by 6. 6y divided by 6, 7x divided by 6, 18 divided by 6. So this would simplify into y equals negative 76x plus 3. These two answers that I boxed are exactly the same as each other. Okay, and again, based upon the directions you read to me, you would get full credit for this answer.
Okay.
Now, wait a minute. What if this was a multiple choice problem
Mm,
and this answer wasn't there, but this answer was there? Okay.
Mhm.
You have to be aware that you can divide 6 into the 7x and the 18, and it simplifies to that. So if this has just been show your work, give me your answer, go on, that's full credit. But if it had been multiple choice and that wasn't there, but that was there, that's your answer. So you got to be a little bit tricky in there. Remember, mathematicians are out to get you. Okay, keep going.
Okay. I have this one. It's the equation, and it says bracket. 5x minus 20 end bracket, or not bracket, the line things, like the
Absolute
actual
value?
line things. Yeah,
Absolute value.
sorry. Yeah,
That's okay. Absolute value.
equals 20, and it says this equation has 2 solutions.
Right. Okay. We did this kind of last night, so this is a good review of that. Okay. In an absolute value problem, what we're actually doing is we're trying to solve this. Okay, we're solving it. For absolute values, the first step we did from last night was get the absolute value alone. Is the absolute value alone? Yes. Okay, then we separate it. But our thinking is something like this. If the answer is 20, see, this is the answer, then inside could have been worth negative 20 because the absolute value of negative 20 is 20. But wait, the inside could have also been worth 20 because the absolute value of 20 is 20. Okay, that comes back to if the absolute value of negative 3 is 3 and the absolute value of positive 3 is 3. Okay, if we knew the answer, we don't know what the original problem is. There's 2 possibilities. That's what this is saying. So instead, what we do is we say, okay, there's 2 possibilities. Either 5x minus 20, the junk inside might have been worth 20, or 5x minus 20 might have been worth negative 20. We don't know. Let me erase it so it's cleaner. Okay, so the game is the junk inside, 5x minus 20, could have been worth either negative 20 or positive 20. We don't know. So we have to write 2 different problems to take that into account. The junk inside is worth 20, or the junk inside is worth negative 20. So we solve this. This gives me 5x equals 40. Divide x is 8. Solve this, add 20 to both sides. That's 5x equals 0. Divide by 5, x equals 0. So this problem had 2 solutions, 8 and 0.
Okay.
Okay. absolute value equations will always, almost always have two solutions. 99 times out of 100. The other time is a trick question. All right, couple more.
Okay, it's another absolute value one. It's
All right,
-4 plus 7, and then the absolute value thing.
okay. -4 plus 7 absolute value.
2x minus 2, and then the end of that, and then equals 10.
Okay, now this is like we did last night.
Yeah, I know you have to add the 4 to both sides, but then after
Good.
that, I kind of get lost.
All right, well, no, that's great. That's a good start. So we add 4. What you're really doing is the key was get the absolute value alone.
Mhm.
Get it by itself, which means you need to get rid of the 4, the -4, and you need to get rid of the 7. Okay, and so you're on your way. You're getting rid of the 4, so that's 7 absolute value of 2x minus 2 equals 14. Now, what's the 7 doing to the absolute value? Isn't it multiplying?
Yeah, so you divide it.
So you're going to divide.
Okay.
Is that okay?
Mhm.
All right. So when you do that, now you have the absolute value of 2x minus 2, boom, equals 2. Now, this problem is exactly like this problem,
Oh, okay.
but you
So there-
had to, I'm sorry, go ahead.
So there's going to be 2 answers
Always.
always. Okay.
Yeah, I'll get you started. So what happens here is you say, if the answer's 2, this inside quantity could have been worth -2, or it could have been worth +2. I don't know. So I write 2 possible equations. 2x minus 2 could have been worth 2, or 2x minus 2 could have been -2. The inside chunk could have been worth 2 or -2, and then solve that. I think you're going to get 0 and 1, I think. Maybe 2. Yeah, 0 and 2 you should get for this one.
Yeah.
Okay. So this is a cool question. Good review for absolute value. That's going to be on the test tomorrow. Good review for isolating the absolute value first. Okay, that's what you have to do. So isolate the absolute value, get it by itself, then split it into 2 problems.
Okay.
Okay, good question. All right, you got more.
I have one more.
Okay.
It's a fraction.
Okay, shoot.
So it's 3/8x.
Okay, where's the x? Is is like this?
Yeah.
Okay,
Minus 1/8 equals -1/6.
okay. And this is that LCD question. Actually, there's a couple of ways to do this, but I'm going to use the LCD. Okay. All right. What's a number that 8 and 6 go into? Not that goes into them, but they go into. What does 8 go into and 6 go into?
Does 8 go into 18 or no?
No.
Mm,
Just run through your times tables real quick. All right. The easiest is to say 6 times 8 is 48.
Mhm.
That's
I'm
the
not
easiest.
good with the finding the lowest common.
Okay, well, the easiest one is just to multiply the 6 and the 8 together. 6 times 8 is 48. The LCD is 6 times 8, which is 48.
So you do
That's,
that with all the problems? That
yeah, yeah.
Okay. Okay.
Now it turns out there's an easier way to do it, and that would be 24. Because in your times tables, does 8 go into 24? Yeah, 8 times 3 is 24. Does 6 go into 24? Yeah, 6 times 4 is 24. So 24 would be a smaller number,
Mhm.
okay? But 48 will work just as well,
Okay.
okay? So that's the easiest way to do it, is to say 6 times 8 is 48.
So when
So
you
let's-
can't find like the
Smallest,
common denominator for both of them, you just multiply it
yeah,
together?
yeah.
Okay.
Yeah, that's the lazy person's way of doing fractions. And I don't mean lazy in a bad way. I just mean if your brain is dead, you're just going, I can't think. Oh, hell with this. You just multiply the two denominators together, and that's your common denominator.
What if there's three different numbers?
Just multiply the three of them together.
All three of them?
Yeah.
Oh, okay.
Okay. But understand the when you multiply three numbers together, you're going to get a big number here sometimes,
Mhm.
right? So you're just going to have to deal with that. That's why we talk so much about getting the LCD, the lowest common denominator. We ask students to think about that. What's the lowest one, the smallest number? 48 will work. Is there a number smaller than 48?
Yeah.
Okay. Yeah. In this case, it'd be 24, but I'm going to go with the 48 here. But to answer your question about 3 fractions or 4 fractions, yeah, just multiply all the denominators together. That'll get you a common denominator. Maybe not the smallest, maybe not the best, but it'll be correct. Okay, so here we go. We're going to go 48 here. So we're going to have 48 over 1 times 3/8x minus 48 over 1 times 1/8 equals 48 over 1 times -1/6. So we distribute the 48 to everybody, and this is the mess we get. Okay, now if life is good, the 48 should cancel every denominator. Okay, it should cancel out, or you use your calculator. 48 times 3 divided by 8. So go ahead and try that on your calculator. 48 times 3, top times top, divided by 8. Should be 18.
Yeah, I got 18.
Okay.
Mhm.
Now, we could have been, the trick way is to do what we call cross canceling. 8 goes into 8 once, 8 goes into 48 6 times. 6 times 3 was 18. But I've just shown you now you have 2 ways of doing it. Again, so we come over here, we go minus, okay, 48 times 1 divided by 8. That's going to be 6. Again, if you cross canceled, 8 goes into 8 once, 8 goes into 48 6 times. Equals, okay, 48 times -1 is -48 divided by 6 is -8. Again, and you can do all those on your calculator. Okay, but you should get down to this step. Okay, notice what's neat about this is by multiplying by 48 and doing a little bit of reducing on each one of these, you suddenly end up with a problem that has no more fractions in it. That's what's so neat about this technique. Students complain, they go, oh, it's ugly. I got to come up with an LCD and I got to multiply fractions. Yeah, but look, no more fractions. It's kind of nice. All right, finish solving this. We're going to add 6 to both sides. So we're going to get 18x equals -2. Divide by 18 to get x alone. Where's the glare? Okay, we're still, well, the 18 is kind of in the glare. So we're going to get x is, now, Negative 2/18 is correct, but incorrect. Your mathematics is correct. You always have to reduce your fractions. Okay, so if you have negative 2/18, you want to reduce, you want to divide top by 2, bottom by 2, always, if you can. Okay, so this reduces to negative 1/9. That's the only correct answer. This is correct, but not completed yet. That's the correct answer, negative 1/9. Okay,
Yeah, I just didn't understand the whole, because the 6 and the 8 threw me off. And I know they go into something, but I couldn't figure
okay.
out.
Again, that's where your times tables. You know,
Mhm.
8 times 2, 8 times 3, 8 times 4, 8 times 5, 6 times 1, 6 times 2, 6 times 3. Yeah. So what does 6 go into? What does 8 go into? 24. 24 would have worked. And if you'd done the problem with a 24, it would have given you the reduced answer right away.
Is
But
that what
this one,
the lowest common does? It gives you the reduced answer?
most of the time it does, yeah.
Oh,
Or you do one extra step at the end to get the reduced answer. It's kind of like, is it that big a deal? I don't know. Okay, but that it's strictly up to you. Mathematicians, because we're lazy, we like small numbers. So we'd rather think ahead of time and use a smaller number here and avoid big numbers later, whatever. But that's just because we're lazy. Okay. That okay?
yeah, that was my last question. Thank you.
Cool. Okay. Anybody else that was listening? Anybody else have a question?
I got a question.
Okay, go ahead.
Do you mind if I share my screen?
Sure, go ahead. Let me see. I don't know if everybody's gonna see it or you're gonna share it. I think I've got sharing on, so. Okay. Nice screen. Oh, okay. All right, which one? Both of them, 25 and 26?
But the thing is,
You're cutting in and out.
can you hear me now?
Yeah,
So this is from your final exam review. Are the questions geared like this? Or
no,
this? Okay. Because like some of the answers, like I don't know what that line is right there. It's like, what
yeah,
is that?
no, we would, that's, forget the line stuff. Just look at the y is less than -1 or y is greater than -1. No, and we'll be using interval notation. So it would be -1 to infinity for the
Okay,
range.
so like the exam is like Lisi's review, like sheet.
Yes, yeah, yeah.
Because this final exam stuff,
The concept is the concept is on the final exam, but most of the problems are going to ask you to answer on your own. There's only going to be a few multiple choice questions. Okay, so I'm going to ask you maybe the same questions. Okay, but you're going to have to put it in interval notation. And the truth is, there's nothing like number 25, not yet, at least.
okay, thank you.
Okay, so don't worry about 25. Let me give me back my screen so that everybody can see. Thank you. Look, what if you had this picture here, and this was 0, -2. Okay, and I wanted the range. Okay, now that what you showed us on your screen was the multiple choice question. I'm just going to give you this and say, what's the range? Not a multiple choice. Well, the range means all the y values. Well, the y values start at -2 and go on forever up. So the range would be bracket -2, comma, infinity. That's how we've been doing it in class. And that's how I'm going to do it if I ask this question on the exam. Is that okay?
Yeah.
All right. And don't worry about that number 25. Okay, anybody else? Oh, excuse me.
I want to ask you if what type of problem that you will put, like a bonus problem.
Oh, can't answer that. Not going to tell you. No.
Okay.
And sometimes I don't even know. Sometimes I'm doing it. I wrote the test. I go, oh man, that problem is worse than I thought. It's an unfair problem. So what I do in the middle of the test while I'm grading is I say, I'm going to make that a bonus. So I didn't mean it to be a bonus, but because I screwed up, I made it into a bonus. Okay. So
Okay.
and number one, I'm not going to tell you that anyway. But if I screw up, I usually turn them into a bonus so that if people get it, great. If they don't get it, it won't hurt them. That's the key. Okay. Anybody else? I'm going to turn off the recording right now anyway.